Have you ever wondered how bridges carry massive loads? How buildings stay upright during storms? Or how machine parts survive extreme forces? Well, it all comes down to something fundamental: the strength of the materials they're made of. In our world, we rely on countless structural elements: bars, tubes, beams, columns, trusses, shafts, cylinders, even spheres. These components might be made from timber, steel, aluminium, copper, concrete, or other materials. But no matter what they're made of, they all share one big responsibility: carrying and withstanding forces. Now here's where engineering comes in. When a force acts on a structure, that force has to be carried safely all the way from the point where it's applied, down to the supports. The science that helps us calculate these reactions at the supports is known as engineering mechanics. But the story doesn't end there. When a structure carries a load, the material itself reacts. It resists, it bends, it stretches, or it compresses. These internal resisting forces create stress, and the structure undergoes deformation. Understanding these internal effects, how materials behave, how much load they can take, and how they fail, all of this is explored in the subject called strength of materials, also known as mechanics of solids. So in this series, we'll dive deep into how structures handle loads, what makes materials strong, and how engineers design safe and reliable systems. If you're ready to understand the science that holds the world together, make sure to like, subscribe, and stay tuned.